Okay, so in the previous video we saw the order of operations. In this video, following on from that, I'd like us to look at a few other rules, also known as laws, which apply to algebraic equations. The three laws that we're going to look at are the commutative law, the associative law, and the distributive law. Now these laws are very simple, so this video should be quite short. And these three laws apply to either addition, subtraction, multiplication, or combinations of those three operations, as you'll hopefully see shortly. Now, it's really important to understand these laws if you want to manipulate algebraic expressions. And given that the ability to manipulate and rearrange algebraic expressions is perhaps the most important element of algebra, it's understandable that knowledge of these laws is incredibly useful. And that's exactly why I'm covering them in these videos. Now you find if you were to go out and look in textbooks for the textbook definition of these three laws, you might find that those definitions can be quite wordy, they can be quite complex, and that's basically because in a textbook they want to make sure that there is only one possible interpretation of what they're saying, and often that means using quite complicated and quite wordy language. However, I'm not worried about the textbook definitions of these three laws. We aren't really mathematicians. We're using maths for an end goal, that is to apply maths to solve problems in programming and computer graphics. That means knowledge of the textbook definition isn't important to us. Knowledge of what it means and how it applies to algebra is important to us. So in this video, I'm not going to be teaching you textbook definitions. I'm going to be teaching you in simple terms what these three laws mean and how they apply to algebraic expressions. So let's start out with the commutative law, and that is spelt C-O-M-M-U-T-A-T-I-V-E, the commutative law. And in my opinion, this is the simplest of the three laws, and it simply states that if you're adding or multiplying two numbers, you can swap those numbers over and still get the same result. For example, if I was taking two numbers and adding them together, 1 plus 2, I can switch these guys over and I'll get the exact same result. So 1 plus 2 is the same as 2 plus 1. And we know that looking at this really basic example, we know that 1 plus 2 equals 3. We know that 2 plus 1 equals 3. So we know that we can switch those over. It also applies to multiplication, so 1 times 2 can be switched to 2 times 1. Again, we know that both of those evaluate to 2. Now it is worth noting that only addition and multiplication are commutative. Subtraction is not commutative. If I had 1 minus 2, that does not equal 2 minus 1. We can see that 1 minus 2 is minus 1. 2 minus 1 is 1. They are not equal. So subtraction is not commutative, and neither is division. If I was to take 4 divided by 2, that is not equal to 2 divided by 4. And we can see that 4 divided by 2 is 2. 2 divided by 4 is 2 over 4, which is the same as a half. And we can see that 2 obviously does not equal a half. Now the commutative law for switching the two numbers that we're either adding or multiplying together might seem a little bit redundant on its own, but it is very, very useful when combined with the other laws because it allows us to know which numbers we can switch and which we can't. And this is especially important when we're not actually dealing with numbers, but rather are dealing with variables. With numbers, I can easily evaluate 1 plus 2. There's no reason to switch those two numbers around because I can evaluate it as an addition. However, when I'm dealing with variables, I might not be able to evaluate those variables. I may not know the value of those variables, and therefore by being able to switch those two numbers around, I may be able to rearrange the equation in such a way that I can work out the value of one or more of those variables. And that's exactly what we're going to be looking at in the next video over rearranging equations. So even though it can seem a little bit redundant right now and very, very basic, it is actually incredibly useful to us when we come to rearrange equations. So that's the commutative law, the simplest in my opinion of the three laws. let's take a look now at the associative law, and that is spelt A-S-S-O-C-I-A-T-I-V-E, the associative law. And this law is also pretty simple. It just states that if you're adding together a series of numbers or are multiplying a series of numbers, then it doesn't matter how you group those numbers together, you will always get the same result. So let's look at an example where we're adding together a series of numbers. So 1 plus 2 plus 3. We could group these numbers in two different ways. We could group the 1 and the 2 together with parentheses, which gives us 1 plus 2 is 3, plus 3, which equals 6. Or, alternatively, we could group the 2 and the 3 together with parentheses, which gives us 1 plus 2 plus 3 is 5, so 1 plus 5, which is also equal to 6. So it doesn't matter how we group the elements, the result is the same. And this is the case no matter how many elements we combine together using addition. Thus, we can say that addition is associative. It abides by the associative law. We can also, having a little bit of fun with this, and just to see some of the power of combining these laws together, we can now bring the commutative law into play. Because we're grouping these elements like this, so I'm going to actually switch to grab this guy back out into its own equation as I think ahead for a second and throw myself for a minute. My apologies there. So I am actually going to grab him on his own and start to manipulate him using both the associative law and the commutative law. So because we have grouped the 2 and the 3 together with parentheses, we know that we must evaluate this part of the expression first. And that means that this part of the expression, 2 plus 3, is going to be evaluated before we use the result. And we've seen with the commutative law that if we had 2 plus 3, for example, in addition, we could switch those values around and get the same result. That means because we're evaluating this first, because we're taking the result of this before we use it anywhere else, we could switch those two values around and get the same result. So 1 plus 3 plus 2 is the same as 1 plus 2 plus 3. Now again, we've seen with the associative law that if we were to group these as we have done here with the parenthesis around the last two values, we could also put the parentheses around the first two values and it's the same. So this is also equal to 1 plus 3 grouped plus 2. And as we saw in the earlier step, if we have grouped these using parentheses, we can switch them with the commutative law. So that is equal to 3 plus 1 plus 2, which again we've seen using the associative law that we can group these using parentheses around the 3 and the 1, or we could use parentheses around the 1 and the 2. So it's equal to 3 plus 1 plus 2. Finally, using the commutative law again, we know we can switch these guys around. So notice what we've done. We have said that 1 plus 2 plus 3 is equal to 3 plus 2 plus 1. We can get rid of the parentheses because we know from our order of operations that these are going to work out exactly the same. We're just adding numbers together. So 1 plus 2 plus 3 is equal to 3 plus 2 plus 1. Yes, it's a very basic example. Yes, it may seem a little bit redundant, but the underlying concept is actually very important. We have completely rearranged the equation on the left to get an equation on the right, and because we have used these two laws, we know the value, the result is the same. And that's the basis of manipulating algebraic expressions, something that we're going to look at in depth in the next video. We're going to be rearranging these expressions, rearranging these equations, and using various laws that we know. It's going to allow us to ensure that we never change the value of that equation, but we reorder it for some purpose to make it more useful to us. So we've seen that addition is associative, and we had a little bit of fun using the associative and commutative laws. But multiplication is also associative. If I was to have 1 times 2 times 3, I can group this in two ways and get the exact same result. I can group the 1 and the 2 which gives us 1 times 2 is 2, times 3 is 6, or I could group the 2 and the 3, which gives us 2 times 3 is 6, 1 times 6, which is 6, and we can see they are the same. Now again, only addition and only multiplication, just those two, are associative. Subtraction is not associative. If we were to have 1 minus 2 minus 3, if I was to group the 1 and the 2 together, that gives us 1 minus 2 is minus 1, minus 3 is minus 4. However, if I was to group the 2 and the 3 together, that gives us 2 minus 3 is minus 1, which is 1 plus 1, because we have two negatives there, which is 2. And we can see that these obviously are not the same, so subtraction is not associative. The grouping of elements does influence the result that we get. So it's only addition and multiplication that are associative. And that's going to conclude looking at the associative law. So I'm going to bring up a new whiteboard layer. And let's take a look at our final law, that is the distributive law. And that is spelled D-I-S-T-R-U-B-I-T-I-V-E, distributive law. Fantastic. This final law is perhaps the most useful of the three laws, but it's also a little bit trickier than the other two. Not much trickier, just a little bit. And so it's going to require a little bit more careful attention. Now, the distributive law basically boils down to this. If you have a series of numbers added together and you multiply that result, it is the same as multiplying each number individually and adding together all of those smaller results. So we can see this with an example. If I had 10 multiplied by 1 plus 2 plus 3, so again we're adding a series of numbers together, we're taking the result of that and we're multiplying it by a number. This is the same as taking that number, multiplying it by each individual element, and then adding together those smaller results. So it's the same as saying 10 times 1 plus 10 times 2 plus 10 times 3. And we can see that as we work through. So 10 times 1 plus 2 is 3, plus 3 is 6, so 10 times 6, and that's equal to, well, 10 times 1 is 10, plus 10 times 2 is 20, plus 10 times 3 is 30. We know 10 times 6 is 60. And I know that 10 plus 20 is 30, plus another 30 is 60. We can see that these are the same. So more generally speaking, sort of using variables rather than numbers, the distributive law says that A times B plus C is the same as A times B plus A times C. And this is really useful because it lets us expand or factorize expressions out of or into parentheses. And being able to do that is incredibly useful for a number of reasons, as we'll see in the coming videos when dealing with rearranging equations. So as we have seen, for example, we can expand, as I scroll back up, 10 times 1 plus 2 plus 3. When we brought that out of brackets like this, out of parentheses, that's called expanding. But alternatively, if I had 5 times 3 plus, 5 times 4 plus 5 times 5, say, I can factorize this, which is the reverse of expanding. I can factorize this into parentheses by saying that this is equal to 5 times 3 plus 4 plus 5. So we've seen that we can expand and factorize using this law. And it's very simple once you get the hang of it, but it's very powerful. Now, it is worth noting that this concept does not apply in reverse. If we were to take our multiplications and make those additions, and take our additions and make them multiplications, it does not apply. So, for example, if I was to have 5 plus 3 times 4 times 5, notice the difference between these two. in one case, I'm adding some numbers together and multiplying the result. In the other case, I'm multiplying some numbers together and adding the result. In this case, it does not apply the law, the distributive law does not apply, and we can see that. We can say this is not equal to 5 plus 3 times 5 plus 4 times 5 plus 5. So if we try to expand this out, we can see that this does not actually work. So we have 5 plus, well, 3 times 4 is 12, times 5 is going to be 60. So 5 plus 60. And we can see that that's not equal to, or 5 plus 3 is 8, times 5 plus 4 is 9, times 5 plus 5 is 10. So 5 plus 60 is 65, and that's not equal to 8 times 9 is 72, times 10 is 720. Quite clearly, these are not equal. And you may say to yourself, well, maybe it's the fact that I've put parentheses in here that have changed the value, because we know that by using parentheses we can change values of equations. Maybe that's what's caused the problem. Maybe I've done this incorrectly. So we could say that, well, what if we were to expand this slightly differently? 5 plus 3 times 4 times 5 is equal to, I'm going to expand it the same way, but not using parentheses. So 5 plus 3 times 5 plus 4 times 5 plus 5. Using our order of operations, that means we need to evaluate these two multiplications first. So that's equal to 5 plus 15 plus 20 plus 5, which is equal to 20 plus 20 plus 5, so that's equal to 45. Well, 65 does not equal 45, so no matter how you approach this, the distributive law does not apply when we have multiplication, or rather addition over multiplication. So when I say addition over multiplication, I basically mean if we have A plus B times C, so we multiply first and then add afterwards, addition over multiplication, the distributive law does not apply. But if we have multiplication over addition, A times B plus C, the distributive law does apply. Now this concept can actually be extended beyond addition to include subtraction, as long as we maintain some simple rules. So I'm going to bring up a new whiteboard, and as long as we're careful and as long as we maintain some very simple rules, we can actually include subtraction. So let's say that we wanted to expand 4 times, and I'm going to say 1 minus 2 plus 3 minus 4. The simple rule really is that the operator that comes to the left of any of our numbers needs to be the operator that we use when we expand that number multiplied by our overall multiplier. Now that sounds really wordy, it's a lot easier to see in practice. So again, the operator that comes to the left of any number. So starting out, we've got 4 times 1. And because we're subtracting 2, the operator to the left of 2 is a negative, a subtraction, we're going to subtract 4 times 2. Then because we're adding 3, we're going to add 4 times 3. And finally, because we're subtracting 4, we're going to subtract 4 times, as I try and squeeze that in, and that's not going to work, so let me drop that down to the next line. So we're going to subtract 4 times 4. So again, we take the operator that's to the left of our number, and we must use that operator when we are summing our result of multiplying our outside number with that number. So 4 times 1 minus 2 plus 3 minus 4 is the same as 4 times 1 minus 4 times 2 plus 4 times 3 minus 4 times 4. And we can see that really quickly because the left hand side evaluates to 4 times 1 minus 2 is minus 1 plus 3 is 2 minus 4 is minus 2. So that is equal to 4 times minus 2 is minus 8. 4 times 1 minus 4 times 2 plus 4 times 3 minus 4 times 4 is the same as 4 times 1, which is 4, minus 4 times 2 is 8, plus 4 times 3 is 12, minus 4 times 4 is 16. 4 minus 8 is minus 4, plus 12 is 8, minus 16 is minus 8. So we can see that indeed they are the same. So there are actually mathematically rigorous proofs as to why this is the case. As a hint, the thing that really made this click in my mind when I originally learnt this quite a number of years ago was that instead of thinking of this as 1 minus 2, think of this as, so instead of 1 minus 2, think of this as being 1 plus minus 2, so 1 plus a negative 2 as opposed to 1 minus 2. If you think of your subtractions as just adding negative numbers, all of this makes a lot more sense. So I'm not going to actually go into the mathematical proof here. I mean, I feel it's more likely to confuse people than clarify my point. But as long as you understand the basic concepts, and as long as you understand that if we are subtracting 2 here, we must subtract whatever we multiply by 2 when we expand it, then you're going to be absolutely fine. And that's all that really matters, is that you can actually use this when you're working, as opposed to necessarily knowing where it comes from and knowing that it is, in fact, proven. And really, this is just going to come with practice. The more you practice expanding and the more you practice factorizing equations and expressions, the more this is going to become second nature to you. And you're not even going to think about the laws or the proofs. It's just going to be a tool that you use and you take for granted in your work. And talking of practice, let's now tackle a few questions where we're going to expand and factorize a variety of expressions. So I'm going to bring up a new whiteboard for these questions. Fantastic. And question 1 is going to be, I want you to expand and evaluate 5 multiplied by 9 plus 4 plus 6, and that is an awful 4. Please excuse my shocking handwriting. So 9 plus 4 plus 6, and I want you to expand that, I want you to evaluate it, and then I want you to compare that result to evaluating this as written. So go ahead and pause the video, and when you unpause, I'm going to go through the answer to this question. Okay, welcome back. There's nothing really complicated here. It's a very simple expansion of an addition of 3 numbers. So to expand this, we're going to say that 5 times 9 plus 4 plus 6 is equal to, well, we take 5 times 9. We add to that 5 times 4. We add to that 5 times 6. If we then work this out, 5 times 9 is 45. 5 times 4 is 20. 5 times 6 is 30. 45 plus 20 is 65, plus 30 is 95. The second part of the question was to check your result against evaluating this as written. So as written, 5 times 9 plus 4 plus 6 is 5 times 9 plus 4 is 13, plus 6 is 19. And 5 times 19 is indeed 95. We can see this very quickly. 5 times 20 is 100. 5 less than 100, because we have 1 less than 20, is 95. So the way that we've expanded this and then evaluated that result is indeed correct. So that's question 1. Let's look at a slightly more complex example now that combines additions and subtractions, because once you get the idea and understand how it works, it's very simple. I can appreciate that when you're first starting out, combining additions and subtractions can be a little bit confusing. So let's go through a question now that uses those. So question 2, scrolling down. Question 2, again, I want you to expand and evaluate. In this case, 3 times 7 plus 4 minus 2 plus 3, and let's say minus 5. Fantastic. So I want you to expand and evaluate that, and then I'd like you to compare the result you get to evaluating this expression as written. So again, go ahead and pause once you have an answer, or if you get stuck, unpause and I will work through the answer. Alright, welcome back. So this is a little bit more complicated due to having additions and subtractions, but if you follow the rule that I set out earlier, if you're adding inside the parentheses, then you need to add that term outside the parentheses. If you're subtracting inside the parentheses, you need to subtract that term outside of the parentheses. Then it's really actually quite simple to evaluate. So we have 3 times 7 plus 4 minus 2 plus 3 minus 5. That is equal to 3 times 7 plus, because we're adding inside the parentheses, plus 3 times 4 minus, because we're subtracting inside the parentheses, 3 times 2 plus, because we're adding inside the parentheses, 3 times 3, and finally minus 3 times 5. So if we work all this out, 3 times 7 is 21, plus 3 times 4 is 12, minus 3 times 2 is 6, plus 3 times 3 is 9, minus 3 times 5 is 15, which is equal to 21 plus 12 is 33, minus 6 is 27, plus 9 is 36, minus 15 is 21. So that's all equal to 21. If we were to compare this to the original expression, well, that's going to be 3 times, 7 plus 4 is 11, minus 2 is 9, plus 3 is 12, minus 5 is 7, 3 times 7. And 3 times 7 is equal to 21. So there we go. They are the same. We have expanded and evaluated that correctly. Now, if you were to get stuck with this question, and I can appreciate that maybe some of you did get stuck with this question, it's almost certainly because of expanding the additions and subtractions. So if you did get a little bit confused, I hope that my explanation of how I worked through and expanded this made things make more sense, made your understanding better of how we expand additions and subtractions. If not, then please either continue watching this video. We're going to be going through some more examples, I'm sure, of addition and subtraction. If not, rewind back to the beginning of the video and watch through again. And if you still have questions, then don't hesitate to get in touch either via the forums or PM me on 3D Buzz. My username is Steve Twist. Get in touch and voice your questions, and I'll be happy to help answer any questions that you might have. So moving on to a question now on factorization. So question 3. I would like you to factorize 6 times 1 plus 6 times 5 plus 6 times 7. Once you factorize this, I want you to compare the result of evaluating that factorized expression with evaluating this original expression. And just as a note, again, factorizing means to put this in the form where we have a multiplication outside the parentheses and some additions or subtractions inside the parentheses. So go ahead and pause the video, and when you unpause, I'm going to work through the answer to this question. Okay, welcome back. Yes, I admit this question is very easy. The way it's written is intended to basically give you the answer immediately and make it very obvious for you, but it's best to start easy and build up. So notice we're multiplying each term here by 6, so we can put 6 on the outside of our parentheses, so it's equal to 6 times 1, we're adding here, so plus 5, we're adding again, so plus 7. So it's equal to 6 times 1 plus 5 plus 7. If we work out this particular way of writing it, we get 6 times 1 plus 5 is 6, plus 7 is 13, and 6 times 13 is 78. So using our factorized version, we get 78. Let's compare that now to the original. So the original gave us 6 times 1, which is 6, plus 6 times 5, which is 30, plus 6 times 7, which is 42. 6 plus 30 is 36, and 36 plus 42 is indeed 78. So we can see that these are indeed equal. So there's an example, a very simple example of factorizing. Let's try a slightly more complicated example. So as I scroll down, question 4. Okay, so I'd like you again to factorize. In this case, I'd like you to factorize 3 times 7 plus 7 times 5 plus 4 times 7. And once you factorize this, I'd like you to evaluate the expression you get and compare that to this original expression. So evaluate both of them and make sure you're getting the same answer. So go ahead and pause the video, and when you come back, we will work through this answer. Okay, welcome back everyone. So this is a little trickier than before, but not really. The only trick here is to remember that multiplication of two numbers is commutative. Therefore, we can rewrite this expression by switching the 7 and the 5 around. And we can rewrite this as 3 times 7 plus 5 times 7 plus 4 times 7. Hopefully that makes it a little more obvious that we're multiplying by 7 in each case. In which case we can rewrite this equal to 7 times 3 plus 5 plus 4. So if we were to evaluate this, we get 7 times 3 plus 5 is 8, plus 4 is 12. So 3 plus 5 is 8, plus 4 is 12. 7 times 12 is going to be 84. Fantastic. And if we were to work out this original expression, we've got 3 times 7 is 21, plus 7 times 5 is going to be 35, plus 4 times 7 is going to be 28. 21 plus 35 is 56, plus 28 is 56, 76, 84. So there we go. They are indeed equal. So for our final question, I want to try something that is just a bit more challenging. It's still fairly simple. And so I am going to need a new whiteboard for this. So let's bring up a new layer. So final question for this video, question 5. It's another factorization question. And in this case, I'd like you to factorize 15 plus 30 plus 25. And once you have the factorized version, I'd like you to compare that against the original expression. So go ahead and pause the video, and when you come back, I will work through the answer to this question. Okay, welcome back. So in this case, it's slightly more complicated because I've not given you the multiplications in this instance. I've just given you 3 numbers added together. But we can work out what we're multiplying. We need some common factor of 15, 30, and 25. Well, obviously 1 is a common factor, but by putting 1 times and then 15 plus 30 plus 25 inside parentheses is really not helping us simplify anything. So it's a little bit redundant. So we need some other common factor. And hopefully it's quite clear that 5 in this case is a common factor because 15 is 3 times 5, 30 is 6 times 5, and 25 is 5 times 5. So we can say this is equal to, I'm going to put the 5 first, so 5 times 3 plus 5 times 6 plus 5 times 5. Written in this form, it's very easy to factorize, so that's equal to 5, 3 plus 6 plus 5. If we were to evaluate this, that's equal to 5, 3 plus 6 is 9, plus 5 is 14, and 5 times 14 is 70. So that's evaluating our factorized version. Alternatively, we know that 15 plus 30 is 45, plus 25, which indeed is also equal to 70. So there we go. They are exactly the same when we evaluate them. They're just different ways of writing our equations. So again, as with the order of operations in the previous video, for the most part this video covered very simple concepts. But again, as with the order of operations, don't be fooled by the simplicity of what we've looked at here. Just because this is very simple does not mean that it isn't fundamentally important. It is. The three laws of algebra, though honestly, after a short while, you won't even think about the fact that you're using these laws when you're manipulating expressions. They apply to every algebraic problem, and thus they're going to apply to almost every scenario in which you could apply mathematics to computer graphics and programming. So they really are important. But like I said, once you practice these, once you work with them, they become second nature. You don't even think about the laws that you're using. You just manipulate the numbers, and you're so sure of these laws, you're so used to working with them, that you don't even need to reassure yourself that what you're doing is correct. You're just so used to manipulating expressions that you can do it without second guessing yourself. So hopefully those of you who haven't encountered these laws before now, or perhaps it's been a while since you studied algebra at school or have worked with equations in this way, hopefully you now have a better understanding and a better grasp on some of the ways in which we can manipulate these various operations. In the next video, I'm going to combine what we've looked at with order of operations and what we've looked at in this video with our algebraic laws, combine that with teaching a little bit on how we approach rearranging equations, and we're going to see how we can rearrange equations to solve for a particular variable. And you're going to notice throughout that video just how important these algebraic laws are and just how important our order of operations are. But that is going to conclude this video. I hope everything has been clear and has made sense, and thanks a lot for watching, everyone.